Alrighty, so here we are with the 4-6 pre-calculus notes on graphs of composite trig functions. So basically a trig with a bunch of other things happening at the same time. So you're going to have to identify if something is periodic or not. So if we take a look at what periodic means, is periodic if there's a positive number c such that when you plug in the c, you end up getting the same function back out. So the idea here is that the only periodic function, even though there are repeating and patterned functions, would be this one right here. Okay, so this is the only one that is periodic. This one is actually kind of a weird loop-de-loop thing, and that's a, so that's if you added an equation on. So notice we've got sine plus x squared, so adding it's not going to make it periodic. Multiplying it does not make it periodic, but again, composite, putting x squared, inserting sine into x squared does make it periodic. Versus the other way, which was putting x squared into sine, does not work. It does look slightly periodic, and especially if you don't zoom in enough, you would think that it is, but because of this piece here in the middle, it's just an even function, and it's not necessarily periodic. So, taking the sine or cosine of trig, whatever it is, and putting it into another function will keep it periodic. So, the next piece here is a sinusoidal function. So basically, of course, because it's got sinusoid, if you can put it into the format of sine, where you've either stretched it or compressed it or shifted it or changed its period or something like that, as long as you can rewrite it as a sine with some sort of value for a, b, c, and d that are constants, that's going to be sinusoidal. So here are some sums that are sinusoidal. So an interesting part is that you can add a trig function to another trig function and it will still be sinusoidal, meaning it can be rewritten as a sine. There are a few things that need to match up. So as we can see here, for the sum of to be a sinusoid, the two sinusoids being added together must have the same period. So notice that inside with, if there were parentheses here, inside the parentheses is the same, versus inside the parentheses here, not the same. And so because of that, those are not going to be sinusoidal. Again here, 3 and 2, not the same, even though they do have like this combo pattern thing going on. Since those are not the same, it's not going to be sinusoidal. However, taking a look at this weird one down here, again, 3/7 x is in all of them. And so because those are in all of them and they match, that means that they are going to have a sinusoidal pattern. So these are going to be sinusoidal. And again, even though it has cosine and sine, and you think, hey, that makes it going to be sinusoidal, it's not, because it actually makes it look a little bit more like this kind of thing going on here. All right. So next piece is called a damping factor. It's actually really cool. The idea is that you end up actually having this equation that bounds the sine, or the sinusoidal function. So it kind of ends up damping it or squishing it. And it's actually really awesome. So this one here is bounded, but it's not damped, because it's actually just made normal, right? This one here is also damped. It's actually, damped by the x squared function. And actually, it's damped by 2x, actually. So the lines, if I make it, as I'm looking at the function here, that's 2x, this is negative 2x, and it's kind of forcing it to be between there. Really cool. So, for each of these, if we have a damping factor, it's going to oscillate between these graphs. Of course, the best way to look at it would be if you could actually graph it, okay? But this one here, you can see that we've multiplied our function. This one is just a multiplied function of a value, and so because 3 is just a constant, we don't actually end up damping. But if it was an equation, because take a look here, we've got 2 to the negative x here, and then we've got negative 2x. If that is a function out front versus just a constant, then there will be damping. So very interesting piece there as well. So that's all it is identifying these pieces, and so the biggest thing you're going to want to do is have your graphing calculator out, or at least a link to that graphing calculator, so that you can actually look at the images, especially after. It's best to see if you can actually do it by just looking at the equation like we have in our examples here, but the best thing to do is to actually see it if you want to double check that you're right.